Hi everybody, and welcome to our first application of relation learning in DataMiner, which is on adding related parameters to your trend graph. Okay, what are we talking about here? Well, as you know better than me, when you're monitoring your network, there are a lot of cases where you need to look at multiple parameters to identify a problem. For example, imagine that you're looking at the temperature of your amplifier. Well, if it increases, it makes sense to compare this to the fan speed of that device or to the fan speed of the room cooling in which the device is located. Another example, say that you have a drop in carrier to noise level. Well, then it makes sense to compare that to the RF input levels to see if there is rain fade or interference or something like that. Another example are bonded interfaces. Basically, they spread the load over multiple interfaces. So these parameters should behave similarly. And when they no longer behave similarly, well, then there is a problem. So these interdependencies between metrics, between parameters, plays a huge role in network management. Now, the feature that I'm going to talk about is going to point you towards related metrics when you're investigating a certain metric. And this can be of great help. Now, as Homer says, it is demo time. So let me show you what this looks like on a system. I'm going to start you off with an example on Zine again, on zine.skyline.be. And concretely, I want to dive into the server free memory example. Here I see the free memory of my server, and I notice that there are these spikes that happen often. And I'm wondering why, what is happening here? Well, let's see if DataMiner can maybe propose me to look at another parameter. Yeah, it can propose me several options. And let me focus on this one. It's telling me to look at the physical memory usage. I click it, and immediately DataMiner adds the physical memory usage parameter to my system. Now, the yellow one is the physical memory usage. The blue one is the available physical memory usage. So of course they are related, and you indeed see that they have this inverse relation. But interestingly, on this yellow graph, I have defined a pattern, namely a DataMiner backup pattern. So now I know that the spikes down on the blue one actually correspond with normal behavior, namely a DataMiner backup. All right, that's a first example where this feature can be useful. Let me show you another example. This one is on another system, but okay, don't worry about that. We're going to focus on the related metrics demo. Let me open this one. All right, what am I seeing here? Well, here I'm seeing the signal level of a beacon receiver. And let me zoom out a little bit to see nicely the historical behavior. Now, maybe you're looking at this signal level and you notice these spikes, basically. And you're wondering, what's going on? Well, here again, you have the light bulb. We click it, and this time DataMiner only proposes one other parameter. Through the relation learning algorithm, it has learned that the signal level on the beacon receiver seems to be related to the forward power of the HPA2 device. Okay, so let me add it. Now, let's see if DataMiner was right. Are these parameters indeed related? Well, in order to see that, let me maybe have a slightly nicer x-axis, split to no axis. And here you go. You clearly see that these parameters are indeed related to each other. All right. I hope this serves as enough examples. Let me just mention a few more words about this feature before finalizing this video. Let me go back to my presentation. Voila. In order to finalize this presentation, let me just mention a few words on prerequisites and computational resources. The main prerequisite for this feature is relation learning. That's why you need a connection to the cloud, as we've mentioned before. You also need a DataMiner version of 10.2.12, 10.3.0 or higher. And to get optimal results, you should really enable behavioral anomaly detection. The reason is that relation learning can be done on the basis of alarms, where we say that parameters are related if their alarms coincide. But you can also do this on the basis of change points, where you say that parameters are related if their behavioral changes occur at the same time. Now, of course, you get better results if you can combine alarms and change point information. So that's why definitely make sure you enable behavior anomaly detection to get the best results. What about computational resources? Well, there's actually nothing to say here. This functionality uses the relation learning. And once you have the relation learning, that's basically all you need. You need a few calculations when you're opening a trend graph, but these are very minimal. So don't need to worry about any of these resources. All right, let me see if there is some further reading. And indeed there is. You have some useful links to the documentation and a blog post on the power of insight. So if you want to learn more about this, definitely check that out. All right, I guess I can conclude here. In the next video, we're going to another application of relation learning. See you there.